Hi, I'm Alex, and I am very pleased to meet you. I assume you're here because you're interested in moving applications to the cloud and managing them there. Very cool. We'll look at some practical tools. We'll look at some use cases that I've seen in startups and in enterprise when my friends have made a similar journey. We'll talk about things like innovation tokens, wise investments in technical debt. We'll explore the world of systems administrations before anyone coined the term of DevOps, and we'll look a little bit into the future. Maybe the world is moving towards no ops, serverless. And don't worry about copying anything down. The slides are available at the end. So a little bit more about me. Um, I'm the Director of Solutions Engineering here at Pythian. My background is as a systems administrator, as a programmer. At some point, the stuff that I was doing got turned into DevOps, and so I did that. Then it became solutions, so I did that. At the moment, I'm learning more about baking bread. So at the end of the talk, if you can find me and if you have any tips for how to keep a sourdough starter going when you've got a bunch of toddlers around, I'd really appreciate that kind of feedback. So let's take a look at who you are. Now, I'm assuming that you have an interest in configuration management because this is what the talk is about. But that might mean that you're coming at this from the standpoint of a developer or a DevOps engineer. You might be coming at this from a solution architect or a systems administrator. I'd like to get an idea of how many of you there are and what your skill set is. So I'm just going to throw out some names, and I'd like you to raise your hands and show me by show of hands where you're coming at this from. So how many DevOps engineers do we have out there? Okay. Do we have any programmers out there? Managers? How about any executives? Neat. So overwhelmingly here we are DevOps engineers and managers. And my guess is that we fall someplace in between, all of us fall someplace in between on that, because we're probably all here to understand how to do this for ourselves and for our teams. Now, I hope that my stories are gonna be applicable to that, and I'll kind of tune them towards that audience. But ultimately, we're all professionals here. I made the bold assumption when prepping for this that whatever your experience level, whatever your current job description, you're professionals engaged in managing complex systems, and that in some way you'd like to bridge the gap from whatever configuration management tool you're already using to some cloud system. I'd like to tell you 3 stories that will lead you in that journey, starting with my own origin story and ending with a description of how cloud architectures can be built and maintained. So this is the first story about configuration management. So before we can go into the modern day, before we can go and talk about what configuration management looks like today, we need to look at what it looked like to me the very first time I started thinking about it. And that was when I was working for a small ISP in central Illinois, managing a couple dozen Linux servers and a ton of these modems. So we didn't all have just IBM hardware, but our server room looked a lot like this. It was our own shelves, we didn't have racks. And I could walk over from my desk and I could touch each of the computers. They each had a special name that were providing this service to our customers. My job at the time was to manage several of these Linux machines. We had no configuration management in place, and we had a new guy that joined who was going to run our news server. And I don't know how many of you remember what a news server was, but it was my job to give this guy access to about a dozen machines. And so I logged into the first one, and I created his account, and I set up his home directory, and I had him confirm it, and it worked just fine. I went to the second one, fine. Third one, fine, right? But then somewhere along the lines, I made a mistake, and he couldn't log in then. And I made another mistake. His home directory wasn't actually writable by him. So these are pretty silly kinds of mistakes. And I had just learned Bash. I had just learned that you can tell computers simply how to do things without actual programming. You could just write a shell script. So of course, that's what I did, right? I put together a Bash script that checked the password file for his account. If it didn't exist, it added it, set the password, and did a few other things. Like, it was probably much more complex than this, but whatever it was, it didn't work. I ran it on all the machines. It deleted accounts. It broke things. And so at that point, I had to go to our senior administrator, who was really just the only other administrator, and confess what I had done. Instead of doing what he probably should have done and telling me to stop messing around with Bash and go fix this for each individual host, we spent the next 3 or 4 hours writing a better version of my script. And I finally got to see what it looks like when you move all of these computers in one go. You get all of them to do exactly what you want them to do all at once. And then we had this repeatable, testable, verifiable process that meant I as a user, I as an administrator, I as a person couldn't screw it up anymore. This felt to me like absolute power. I could control 12 servers at once. And for me, that's what configuration management is. All of the declarations that we write, all of the recipes that we write, all of those things come from the idea that there are lots of computers and we need to manage them. And as we manage each of these computers, we don't want to have to do the same thing twice. And when we do it, we want to make sure that it's done the same way each and every time. People are bad at this. Computers are good at this. That is configuration management. Now, of course, I've moved on from there. The story of configuration management is constantly changing. I had part in writing a very small configuration management suite when I was at the University of Illinois. I don't think it still exists. I couldn't find a graphic for it. But I'm familiar with all of these, and all of these are now the future. This is where we are as an industry in the way that we look at configuring hosts, configuring VMs, configuring bare hardware. But that may not be where we want to go. And that's where I want to take us next. The second story that I'd like to tell you is about when to chase the newest thing, when to look at new technology and decide this is the thing I want to use today for whatever reason, and when to decide that this new exciting thing isn't the right thing for you. And this is particularly applicable when we talk about embracing the cloud, because everyone is going to be talking on Hacker News or whatever your favorite tech blog is about all of the new interesting things that could make your life easier. But at the same time, you've gotten very good at using the things you already know. So how do you make that choice? Now, I would imagine any company that has gone through a decision-making process for whether or not to adopt cloud resources, they have got a list like this. It's a bunch of pros and a bunch of cons. None of them actually matter, but you got to write them down and you got to talk about them for 2 or 3 hours before you make any sort of a decision. I like this, but I think it leaves some. I think it's exhaustive, and I think it leaves things out. And ultimately, you're going to do what you want to do, even if it doesn't end up being the thing that you have to do when you're innovating. And you'll tell yourself that that's the best part. So I like to give myself an innovation token, something that prevents me from doing too much too fast and hones my decision-making process. Now, I can't take credit for this. At the end of the slide deck, we've got references to the first places that I found this online. But I heard about this originally from Mark Verlot, the core of the operations team, when I joined Linden Lab as part of their ops team. He adopted the idea of innovation tokens, and my explanation of it is heavily influenced by him. He's currently in the startup world where teams routinely start new projects or even new companies without an existing tech stack, but with an accumulation of knowledge around what's broken badly in the past. Innovation tokens, to those of us from an ops background, are our hints. When we spend one, we're pointing out to ourselves, this is what's probably going to break in an unexpected way. And when we limit the things that are likely to break in an unexpected way to a few, it helps to control our operational complexity. So the model that he uses and the model that I use is that you give yourself 3, and you invest 1 each time you add something to your production stack that you've never run in production before. You may have played with it a lot at home, but if you've never run it in production before, it fails in different ways than you think. And so you should spend a token on that. So you start with 3. Let's assume you're moving to the cloud. You've decided to embrace AWS. And instead of spinning up new servers when load spikes, you decide that you're going to use autoscaling. Now, autoscaling is a great feature, but since you don't know what it looks like, there's some surprising ways that it decides to add new hardware. And it can get stuck in a loop where it's constantly adding hardware and it's having no impact on the thing that you thought you were measuring, which is bad for performance because you're not actually fixing performance. And it's bad for cost control because all of a sudden your usage of AWS has ballooned and you don't know why. So this is not the kind of thing that people normally associate with autoscaling, or at least the first time they do it, they don't. This is how an innovation token ends up coming in handy, because you knew that that was the thing that was new for you. So you've got auto scaling in place and you decide, okay, now part of why we're having this new problem that we didn't think about in auto scaling is service discovery. So now we have to figure out how these new systems are gonna connect, how they're gonna know that each other's online. We're gonna do that through the load balancer or whatever. But we've never done service discovery before. We've always done pre-baked maps that we send out to every instance to tell all of the other instances where they live. So this is an innovation token. So now that you've spent 2 and you're still on the same project, what's your next one? Is it really worth putting CloudFormation in place because you know that you can't do anything else new? Is it really worth moving on to the infrastructure as code piece? So some places to invest these tokens are moving from on-premise VMs to cloud VMs, introducing the immutable state, which I'll talk about a little bit later. Microservices and Docker and things like that, those are tiny and they appear small, but they expose dozens of possible craziness. So be very careful. Infrastructure as code, it's beautiful, I love it. But if you've never done it before, it fails in interesting ways. And you can take down your whole infrastructure. When you move from a SAN to a distributed file system, when you adopt containers of any kind, and of course, if you add a new language to your stack, I have spent tokens on Node.js, Golang, and Haskell. I would probably spend another token on Haskell if I put it into production again, because I still don't feel like I understand it. So the third story here, after covering first where configuration management came from and how to limit your exposure to danger, I want to talk about building on your strength. And I want to use a story of a friend of mine's company that made the switch into the cloud using a configuration management technology they're already heavily committed to. I call this story "Don't Overthink It, Use What You're Good At." So a little bit about my friend's company. He was a managing infrastructure. He was a infrastructure manager, or I don't know, managing director, something like that, of this dev team. 50 to 100 servers in the colo, 3 engineers. They all share the pager. They were over-provisioned in the colo by 30%, so they were pretty comfortable with growth. And they had gotten very, very good at Chef. Tuning everything, data bags are happy, encrypted data bags, all that stuff. So they had gone all in as an ops team and said, Chef is our answer. Whatever the problem is, Chef's our first answer. And if we can't solve it with Chef, then we'll move on to something else. Now, that's all well and good, but as the mechanics that keep everything stable underneath an application, the application can sometimes do things we don't expect, like go viral, and all of a sudden we have growth that is astronomical. Those 30% servers, that 30% of over provisioning that you did, you blow through that in like a week, and they did, right? And now they're trying to figure out how to squeeze every possible CPU cycle out of what they've got, and also how to plan for future growth and how to not stall out, because you don't want to lose that trajectory as a company, more than just as an ops team. So it's time to scale really fast. AWS was new at the time. Servers are just servers. Chef can handle more servers, no problem. So they sign up for AWS first time. and they start dumping they just start dumping servers into AWS as fast as they possibly could, treating them just the same way they used their existing on-premise co-located servers. Wow. So the pace picks up. He and his team were spending more time and more time trying to figure out why the VMs were crashing in AWS, but they were not crashing on the regular hardware. You find the Chef runs were taking so much longer, and they don't know why. It doesn't seem to scale linearly with adding more servers, and it probably should. So what's going on here? They can't figure out which servers are up and which servers are down, which servers are actually providing service and which aren't. And so it's a lot of small problems that lead up to the fact that you have gone too far too fast. So it's time to stop. And what this team did is they drew up a list of ways to address this. Now, this is the point where an ops team goes a little bit nuts. I'm sure you've all been there before. It's not fun, but it is the best thing you can do to just assess the situation. And they came up with these choices. We can retreat from the cloud. We can hire more people. We can switch to Puppet, because in any team of 3 configuration management engineers, at least one of them hates the tool you're using and thinks another one is better. Doesn't matter how big the team is, this is always true. Or they could adopt immutable infrastructure. And what my friend decided to do was adopt that immutable infrastructure. Stop caring about individual machines. Stop caring about how they fail. When they are not working, immediately call them from the infrastructure. So this is a cloud pattern that I love. The disposable instances mean that the Netflix Chaos Monkey can delete any running instance at any time. Things will keep on trucking. Since they already had Chef in place, they knew how to make a perfect server in the abstract. They can do that with a tool like Packer, and now they've got a fully provisioned host. Well, that's pretty neat. So once you've got a fully provisioned host, you can store that image in the cloud, and you can add tags and metadata about who built it, when, why, what were the differences. So now when you need a new service, you can just start with a bunch of new VMs that you know are clean and that you know have no state within them. So that's a neat, this is a new way of using infrastructure, at least it was for them. So they built something that looks like this. I said, okay, we're gonna have Jenkins kick off build using Packer. We're gonna provision our instances with Chef. We're gonna use Kitchen CI to test that everything is working. We're gonna upload those new AMIs to Amazon with a tag, with a version, with a deployment number, whatever, and then we're going to roll those things out. So this actually helped them. They ended up taking the Chef knowledge they already had and using that to move into a new exciting cloud platform. So ultimately, they moved away from instances that are built this way. They moved away from Chef. I believe they're now doing a bunch of their work with lightweight instances and microservices, and the world is a better place. But their journey was a tough one, and the ultimate destination was cloud, but the way they got there was configuration management. So let's review. We talked about what is configuration management. We decided how we might want to use new stuff. And I gave you an example of how to use a tool you already know in order to do this migration stuff. But what we haven't talked about, and what I think is most interesting, is what's different with cloud infrastructure. What is cloud orchestration? So a reasonable question is, are immutable instances the best I can do? Is Docker just another VM for me to manage? But that's still thinking about the individual instances, the computers, the VMs, the servers. What's so much fun about this point in history is that we're watching something totally new happen. Google, Microsoft, and Amazon are trying to define what a cloud is and how to work with it, and whether the concept of a server is still something that we should care about at the consumer ops level. And because of that, a different strategy is at work with each cloud provider. AWS is the king of building blocks. Each service builds on the API of the ones before it. They're all tied together through a consistent authentication and authorization system that works well and they all mirror things that we've been building on our own for the last few years. Microsoft sees integrated products as the future. They bundle, they provide APIs, they think about what consumers are probably going to want and try to build those products rather than talking about specifically the building blocks that get you there. And Google is expanding their own internal cloud platform to us gradually as they improve it, so that we don't ever have to think about where it's running. We don't have to think about instances. We don't have to think about data centers. We think about latency. We think about SLAs, and we can start moving towards a world where we don't think about it other than it being in Google's cloud, like whatever it is. So I'm going to go through this a little bit in a little bit more detail. First of all, the Google Cloud Platform. It's got VMs, storage, databases, machine learning. It's got Bigtable, which I think is pretty neat. It's a product that puts a ton of data at your fingertips in an SQL format, and that's pretty neat. It's got data flow. It's got genomics. I didn't know it had genomics until I started doing this research. I don't know how I'm going to use Google Genomics, but now I want to. And I was going to put numbers of services on these slides, but honestly, I can't keep up. And I can't even find a full listing of all of them in one place. Next one is Amazon Web Services. This is the one I came into this most familiar with. Many services. And so once again, we see VMs, we see containers, we see storage, databases. We have a machine learning platform, but we also have this thing called Lumberjack, which is a video game design platform. We have OpsWorks, which is sort of Chef orchestrated within the cloud, but there's some neat twists to it. And we've got this crazy thing called Device Farm, which allows you to test your new mobile apps on hundreds, if not thousands, of devices all at once in a pay-per-use model. That's pretty neat, and it's not something that you see from all of the different cloud vendors. And you look at Azure, once again, VMs, container storage, database, machine learning, but they've got some neat stuff like the Face API, which is built into their Xbox product. It can recognize me as I walk up to it, but it's made available through a single API call to those who decide to integrate the IoT frameworks from Microsoft. And not only that, you can actually use it as a RESTful interface from anywhere, including one of the other clouds. It's getting better at differentiating between faces, and they're using some of that of what they've learned to create things like the Emotion API. And they've got this great product that I've been playing with called Stream Analytics that is what it sounds like, and it abstracts a lot of the hassle of streaming lots of analytical data and then working with it. These represent different, there's a core piece of all of the cloud platforms that's the same, but the way that they diverge is interesting because it hints at where specialization might happen or where future consolidation might happen. And so while you can look at the least common denominator for each cloud and say, okay, well, they all provide VMs, containers, they can all do a serverless thing, right? They all do networking and VPNs. And with something like Terraform, or which is an open source product, or RightScale, which is a company that does like abstract cloud deployments, you can easily move to the lowest common denominator and say, okay, I'm going to build something that can run on any cloud. But I'm not sure you want to, because in the same way that configuration management is all about moving from one cloud, controlling many computers at once, I think cloud is going to be about doing interesting things with APIs all at once. So I want to touch a little bit on some cloud-specific architecture. Zappa, for instance, is a web framework built around AWS Lambda. I'm sure that there'll be other versions of this for the other serverless clouds, but it's pretty neat and it's worth checking out to see if this is what the future of applications might look like. NoOps is this term that says as we start relying on the cloud more, operations will not be needed. There's a great conference called Serverless Conf where I was glad to see that NoOps is being debunked a bit, but I still think that there's less ops going on, and we have to figure out what that's going to mean. Azure Stream Analytics is turnkey, and you can just use it. BigQuery is petabyte scale, SQL compatible database solution, and you can do all kinds of neat stuff with it. People compare it at times to AWS's Redshift, but I think it provides some features that are totally different than the way that Redshift sees them. So go take a look at these, see if they're right for you, and make your cloud journey into a cloud that supports what you care about, as well as providing the lowest common denominator that they all do. Because for the lowest common denominator stuff, all of the clouds are getting similar, and all of the clouds are aggressively pricing themselves so that they want your business. So finally, let's go to takeaways. Configuration management has traditionally been about managing servers individually or in groups. Cloud orchestration is about thinking less about the servers and VMs and more about the services they provide. The future of applications may be completely serverless, but we don't know that yet. And don't panic if configuration management is what you're good at. It is, if it's what you're good at and you can use it in a new way, then there's no reason to abandon it. And one of the things we didn't really talk about here is how each configuration management tool can interact with the clouds, but I feel like it's worth putting in as part of the last slide. They all do. All of the major configuration management tools can do any of the things we're talking about. So just read the documentation and go for it. And finally, have a strategy for trying new things. I like innovation tokens. There are alternatives. Please go ahead and read the inspirations and references because I think you'll find that there's a lot out there about how to move forward, how to limit your risk, and how to migrate to the cloud using configuration management. So thank you very much. This has been Alex Lovell-Troy, and I'm still very pleased to have met all of you.